Now we're recording. Okay. Uh-oh, what happened now? Now that we're recording, it decides to act up. Here we go. Come on. Forget it. I'll just leave it as it was. We don't need to put it into the big mood, I guess. Okay. Anyway, here we go. Okay, so as I said, solution is combination of solvent and solute. Solvent is the higher concentration, solute is the lower concentration, and we can have more than one solute. So you can have, again, like that Kool-Aid example, you can have water and then Kool-Aid and sugar. Kool-Aid and sugar are both the solute. Okay. And just remember that a solution is a homogeneous mixture, so it looks the same throughout. Okay, it looks the same throughout. When we talk about solubility, the solubility is the maximum amount of solute that will dissolve or disperse in a solvent at a given temperature. And temperature and pressure do matter. So temperature and pressure do matter. Okay, as you change temperature and pressure, you're going to change the solubility. Okay, in general, solubility for a solid going into a liquid increases with temperature. So the solubility increases with temperature when you're talking about a solid into a liquid or two liquids together. However, if you have a gas into a liquid, so if it's like carbon dioxide dissolves into water, the actually as temperature goes up, the solubility goes down. Okay, so that's one of the reasons why for oceans. So if you have the oceans getting warmer, they absorb less and less carbon dioxide. So we're going to have more carbon dioxide in the air. So it's kind of like as the oceans heat up, the carbon dioxide goes up, which warms the oceans, which increases the amount of carbon dioxide, which warms the oceans. So they kind of like keep going on and on and on, right? And the ocean is actually the number one largest carbon dioxide sink, right? That's where all the carbon dioxide actually goes. It really goes into the ocean. Okay. Now, molar solubility is just molarity. So the number of moles of solute that dissolves in exactly 1 liter of solution. So molar solubility is basically molarity. Just the concentration, the maximum concentration in molarity of solute in solvent. So the maximum amount. Okay. When we're talking about two liquids together, two liquids can either mix, we call that miscible. So when two liquids can mix, we call that miscible. And when two liquids do not mix, we call that immiscible. Okay, when two liquids do not mix, we call that immiscible or immiscible. Okay. I think tomorrow we're going to talk more about those principles of solubility. Because I'm going to have you do some work on that, but I'm not having you do work on that today. I'm just having you do the math for right now, but whatevers. Next one, next slide here. Why is it? Oh, do not like, okay. The rule for solvation is generally like dissolves like, as you probably know already. Okay, polar dissolves polar, non-polar dissolves non-polar. So polar dissolves polar, meaning like water will dissolve something like salt. Water has a positive and a negative end. Salt has a positive side and a negative side. Okay. And then non-polar dissolves non-polar, so something like oil and gasoline. And basically, the more alike two molecules are, the more likely they are to dissolve one another. Okay. That's basically because if you have a strong attraction between solvent particles, right, or whatever the attraction between solvent particles compared to the solute particles, they're not gonna mix if they're not equally attracted to one another. If the solvent is really attracted to the solvent and a solute comes in that's not so attracted, it's not gonna mix. Okay. The intermolecular forces between the solvent and solute have to be similar. Okay, they have to be similar to one another. Okay, because they have to basically act like they're the same thing. They have to act as if there's no change, right? It's kind of hard to explain, but they have to be very similar to one another. Okay, and then this again here it says the solvation process of dissolving particles of solute will dissolve if it is more attracted to the solvent than to itself. So I would say that they have to be equally attracted to one another. Okay, now yes, if the particles are, if the solute particles are more attracted to the solvent, then they will dissolve for sure. But it's either they have to be more attracted to the solvent or equally attracted. They can't be really less attracted, right? Because it will work if they're the same attraction, and really the strong the yeah. I mean that makes sense too, but in general, it's the idea is that the more alike they are, the more they're going to dissolve with one another. Okay. So we can have three different types of solutions. We can have a saturated solution. Saturated solution means that they contain the maximum amount of solute that will dissolve under a given set of conditions, temperature and pressure. And in that instance, there will be a dynamic equilibrium between the dissolved and undissolved particles. So usually a saturated solution has more particles, like there'll be solid particles at the bottom of the solution. I mean, you could do it just enough. If you add just enough to get it saturated, and then you can not have the particles at the bottom, but usually you'll have particles at the bottom. And those particles are in a dynamic equilibrium, so some of them are going into solution and some are coming out. So they're going in and out, in and out, in and out of solution. Okay. An unsaturated solution contains less than the maximum amount of solute. Okay. So unsaturated means you can add more solute in there and it's not going to do anything. You can just keep adding it until it gets to a point of saturation, right? You'll see this on like a curve like this. So you see a curve like this. This shows you the This shows you the temperature and the solubility. So you see as temperature goes up, generally solubility goes up. So as we increase temperature, generally solubility goes up. Okay, and this is grams of solute in 100 grams of water. So sugar, you can put 180 grams of sugar in 100 grams of water at 0 degrees Celsius. That's kind of crazy, right? You put more sugar than there is actually water. There are a few substances, though, that actually they decrease in solubility as you increase the temperature. So those are the ones in the red. But that's what this looks like. Okay. We're going to do some work on that another day, not today. And then finally, we have a supersaturated solution. So a supersaturated solution is if we took a solution that is saturated at a certain temperature. So let's say, for example, we did a solution of potassium nitrate at 80 degrees Celsius, and we put 180 grams of potassium nitrate into the water there at 80. Okay, and then we cooled it down to 20 degrees Celsius. Well, what would happen is actually that solution, the potassium nitrate would stay suspended in the solution. Okay, it would stay suspended in the solution. So there would actually be more potassium nitrate in the solution than we would predict in a saturated solution. So we call it super saturated. So it's above the saturation point. Okay, and this is a really unstable. This is an unstable state. It's very, very unstable. Okay. Something as simple as like moving it, like shaking it, stirring it, touching it, will cause it to come out of solution. Okay, so I have this video here, and this guy, he created this super saturated solution here. And what he's going to do is going to add so right now the solution is pretty clear. He's going to add a tiny amount of the crystal, and then when he does that, it's all going to come out of solution. So let's just kind of go forward here. He explains it. I can include a link in here. So you'll see it. He added that little. Let's go back here. He added a little bit of the salt, and then you see it coming out of solution here. That's because it was super saturated. Okay, so that I mean, you just Google super saturated solution, you can find lots of explanations on that one. Okay, so that's a super saturated solution. Okay, the last thing here that I want to talk about is just the different ways we measure concentrations of solution. So we're only really going to be using these ones. Molarity, which you know already, number of moles per liter. The mass percent, so this is the grams of solute over grams of solution times 100%. Okay, that one's pretty simple too. And then mole fraction. Mole fraction is the ratio of the number of moles of a given substance over the total number of moles. So it's just a fraction. It's part over whole. Part over whole. And when we talk about part over whole, we're talking about the solute usually over the solvent plus the solute. Okay. This symbol here, it's pronounced chi. It's a Greek letter chi. Okay, and then usually you write chi with the little, like if you use the element symbol underneath it. Okay. And lucky you, a lot of this unit is kind of like actually tossed out the door because we don't do anything on calculations involving colligative properties. We're going to talk about the principles behind colligative properties, but we're not going to talk about calculations. All right. That's it. The work is to just practice this stuff, and I have the answers at the bottom of each section for the worksheet today. So molarity, then I have the work, and then percent by mass, and then I have the answers, and then the mole fraction, and I have the answers there. Okay, so give that your best shot. If you do have any questions, I can answer them tomorrow. And we'll kind of be going over some more theory stuff tomorrow. Okay, does anyone have any questions? You could do it today. It's fine. I'm not going to mark it late. Let's see, what day is today? Thursday, Monday, Tuesday, Wednesday, Thursday. Yeah, that was supposed to be for yesterday. But yeah, just try and get that done